You need to determine the density of an unknown liquid. You notice that a wooden block floats in this liquid with 4.6 centimeters of the side of the block submerged. When the block is placed in water, it also floats but with 5.8 centimeters submerged. What is the density of the unknown liquid? Here, this is based on the flotation or the buoyancy and also the Archimedes principle. Okay. Here you see the picture is given to us. The block first kept in the liquid, unknown liquid. And then when the block is kept in unknown liquid, 4.6 centimeters of the side of the block is submerged. Then it was cleaned and then kept in water. Then 5.8 centimeters of the side submerged in water. Now we have to find out the density of the unknown liquid. Now, according to Archimedes' principle, whenever an object, either partially or completely immersed in a liquid, the liquid exerts a buoyant force, and that buoyant force is equal to the weight of the fluid displaced by the object. Okay, that is the Archimedes principle. Now, before going into the details, let us see when the object floats, when the object sinks, and then when the object be in neutral buoyancy. Okay, so here you can see three pictures. In this picture, this is the buoyant force, Fb is the buoyant force, and W naught is the weight of the object. Suffix O represents object. Okay, suffix B represents buoyant force, buoyancy, or okay, buoyancy. Now, if you see the arrow marks, this Fg or W naught is greater than Fb. Okay, so these are the forces I will write. W naught is nothing but Fg, Fg of the object. Okay, so Fg object is greater than Fb. That indicates that the density of the object is greater than density of the fluid. Okay, I write here rho naught is greater than rho F. Suffix O represents object and then F represents fluid. Okay, I write here O is the object. Suffix O is nothing but object. And then suffix F represents the fluid. Okay. Now comes to the object floating in on the fluid. Here you see the arrow mark, downward arrow is smaller than the upward arrow. This indicates that the buoyant force is greater than the weight. That indicates the density of the fluid is greater than density of the object. Okay, that means the density of the object is less than density of the fluid. And then here, if you see, both the arrows are equal. Am I right? The length of the arrows are same, FB and FG. So that indicates that the density of the object and the density of the fluid are same. Okay, so rho naught is equal to rho F. So these are the conditions under which the object sinks, the object floats, and then object has neutral buoyancy. Now, according to the Archimedes principle, the buoyant force is equal to Fg of the fluid displaced by the object. Fg is the weight of the W, that is equal to weight of the fluid displaced. Okay, now we have to write this in terms of density and then density in terms of density, because we have to find out the density of the unknown liquid. So we know W is equal to mg, am I right? And then density rho is equal to mass by volume. This represent, from this we can find out m is equal to rho v. Am I right? Now, here we will write the equation. Fb is equal to W, no? So let us write the equation for the unknown liquid and also for the water. Okay. So for from this we can write W is equal to this and this combining. We can write W is equal to rho v g. This is the general equation. Okay. Now for now we write the weight of the object and also for the unknown liquid, fluid, etc. Okay. Then W is equal to W. First we write for the object. W naught is equal to rho, that means rho naught, that means object. Rho naught V naught G. This is the weight of the object. Weight of the object. Okay. And then similarly, I will write for the fluid. Okay. W fluid is equal to rho fluid, V fluid, and then G. Okay. So this is weight of the fluid. Understood. And then next what I do is I will write for the water also. Then how it will be W water, I will write. W water is equal to rho water, V water, and then G. This is the weight of the water displaced by the object. Okay. Weight of the object, weight of the water displaced by the object. Even here, this also the same, fluid displaced by the object. Okay, now FB is equal to uh, Fg or W, weight of the fluid displaced by the object. Here that will write displaced by the object. Okay, then I will write this one for the fluid and also for the water. So F point is equal to Fg. Am I right? So W object is equal to W fluid. Am I right? So rho naught V naught G is equal to rho F Vf G. Okay. And then similarly for the water, rho naught V naught G is equal to rho water V water G. Okay. So when the object is placed in the fluid, this is the case. And then when the object is placed in the water, then this is the case. So W naught is equal to W water. Then this is the case. Okay. Now both the left hand sides are same. So I can equate the right hand sides. Am I right? So rho F Vf G is equal to rho water V water G. So G cancels out. Now I am left with this one. Am I right? Rho fluid is equal to rho water V water by V fluid. Okay. Now, what is the volume? I write here. Volume is equal to area of cross section times H. Okay. Now, when it comes to the this one, then I write here rho F is equal to rho water. Rho F is equal to rho water. Volume of the water is equal to area of cross section into how much the block submerged here, 5.8 centimeters. 5.8 divided by A times 4.6. Okay. Now A cancels out. I'm left with this one. So rho fluid is equal to rho water times 5.8 divided by 4.6. 5.8 divided by 4.6 is equal to 1.26. And then rho water is equal to 1. So I write here, rho water is equal to 1 gram per cc. So this is 1.26. So 1.26 means glycerin. Okay. So you may be wondering, so here he gave in kilogram per cubic meter. I will convert it. So 1 gram per cc is equal to 1000 kilogram per cubic meter. So this is equal to, this is gram per cc, or that is equal to 1260 kilogram per cubic meter. So that means uh, this is the density of the fluid, and it is nothing but glycerin. The fluid is nothing but glycerin. Understood? First, you should know when the object sinks, when the object floats, and when the object will suspend in the fluid. Whenever the density of the object is greater than the density of the fluid, it sinks. That means it goes down the fluid. Okay. It will stay at the bottom of the container. Okay. And then next, when the density of the object is less than the density of the fluid, then it floats. Okay. And then third one, when the density of the object is equal to density of the fluid, then it suspends in the fluid, and then it will stay like that. That means it is in static equilibrium. So here in this case, the object is floating. So a part of the object is submerged in the water. So according to this one, these two things, according to Archimedes' principle, the buoyant force must be equal to the weight. Okay. So whenever an object is partially or completely submerged in a fluid, then the buoyant force exerted by the fluid is equal to the weight of the fluid displaced by the object. This is the Archimedes principle. So according to Archimedes principle, FB is equal to Fg is equal to W. W is the weight of the fluid displaced by the object. Okay. Now W is equal to, we know W is equal to mg, and then the density is equal to mass per volume. Therefore, mass is equal to density times volume. Okay. So W is equal to mg. So W is equal to rho Vg. Now we will write the equations for the object, fluid, and water. Okay. For the object, it is weight of the object is equal to rho naught V naught G. And then for the fluid, it is rho F V F G. And then weight of the water is equal to, that means weight of the water displaced by the object is equal to rho water V water G. Okay. Now we will write for the, first we are placing the object in the fluid, and then we are placing the object in the water. Okay, first unknown liquid and then later in the water. Now when we kept the object in the unknown liquid, that means I am representing it as F fluid. Okay, so rho naught V naught G is equal to rho F V F G. And then next we are placing the object in the water. So rho naught V naught G is equal to rho W V W G. As the left hand sides are equal, same, we can equate the right hand sides. So rho F V of G is equal to rho water V water G, and then rho F is equal to rho water V water by V unknown liquid. Okay. And now we know volume is equal to area into height. So height is given to us. Height means the length of the object which is submerged in the either unknown liquid or in the water. Both the cases, the data is given, data points are here. So using those data points, we can find out the density of the unknown liquid. So we got the density of the unknown liquid as 1.26 grams per cc or 1260 kilograms per cubic meter. And this is nothing but the density of the glycerine. Therefore, the unknown liquid is glycerine. Okay. This is how we have to solve the problem. Here, two concepts are involved. One is the Archimedes principle, another one is the buoyancy or the flotation. Okay, when the object floats, when the object sinks, that you should know. Here, we are clearly representing the forces with the arrow marks, and then the length of the arrow clearly indicates in which direction the force is more, in which direction the force is less. So from this, we can easily make out when the object floats and when the object sinks and when the object will be in neutral equilibrium, static equilibrium or neutral buoyancy. Okay. Hope this helps. Thank you. Bye bye.